This is technically our third day, our third video on this same section on graphing parabolas. And we've already gone through all of these notes right here. Not only that, we jotted down these very important notes on quadratic trinomial functions. The first thing that I had you write down was vertex, because that's what you always find. That's the most important point of your parabola. And how do you do that? You simply use the formula x equals negative b over 2 times a. You get your b from there, your a from there. You work it out. You get an answer for x. And then you plug in that x value to solve for y, and you'll have your y value. Okay? So that's how to find the vertex. And then after finding the vertex, you draw a vertical line right through that vertex. That vertical line is called the axis of symmetry, and it's always going to be the equation x equals whatever that x value of your vertex is. So once you have your vertex and your axis of symmetry, you need some points. The easiest point to find is the y-intercept. Now, you don't have to find the y-intercept. You could jump straight to the pattern, but it's really easy to find the y-intercept. It'll always be 0, your c value. Because to find the y-intercept, all you got to do is set x equal to 0. And if you set these x's equal to 0, everything will cancel out except for the c. So to find the y-intercept, you set x equal to 0, and it'll give you the answer c. So the y-intercept value will always be 0, the c value. So that's the quickest, easiest point to find, 0, whatever this number is. Now, let's say your a value is 1 or negative 1. You could use the pattern 1, 1, 2, 4, 3, 9 from the vertex. Obviously, if the a value were negative 1, it'd be 1 over 1 down as opposed to 1 over 1 up, or 2 over 4 down, 3 over 9 down, if the a value was negative 1. But what if your a value is not 1 or negative 1? Let's say your a value is 2. Then you could modify your pattern to whatever your different a value is. So if your a value is 2, let me zoom in on this. If your a value is 2, you could modify your 1, 1, 2, 4, 3, 9. You could modify the outputs by your new a value of this, in this case, 2. So 1 times 2 is 2, 4 times 2 is 8, 9 times 2 is 18. So instead of 1, 1, the new modified pattern is 1, 2, and then 2, 8, and then 3, 18. Anyway, last but not least, domain and range. The domain of any parabola is x equals all real numbers, and the range of any parabola is going to be y is either at or above the vertex y value, or at or below the vertex y value. So whatever your vertex is, it's at that. It's either going to be y is greater than or equal to the vertex y value, or y is less than or equal to the vertex y value, depending on if the parabola is opening up or down. So we have all these notes down from the previous 2 days, and we're going to now continue to apply these notes on the back side of our notes, which is the practice portion of it. So we've copied, or we've done a couple of these yesterday. We did some straightforward ones where the a value was 1. We did one where we had to modify the outputs of the pattern because the a value is 2. Let's get into the really nitty gritty. Let's do the hardest ones here with the a value of 1/2 or the a value of negative 1/3. Which one would you like to see first, the 1/2 or the negative 1/3? 1/2. Okay, this one is really interesting. For sure, it's going to be opening up because it's positive, and it's going to be wider than usual because it gets vertically compressed. The closer that the a value gets to 0, the wider that it gets. Anyway, how do we start graphing any parabola? We're going to begin by finding the vertex. So everybody go ahead and write down vertex. This one's going to be crazy, all right? If you understand this one and the next one, you'll understand graphing any parabola in standard form. So to find the vertex, we need the vertex formula x equals negative b over 2 times a. And when we use it, we're going to use parentheses when we plug in. And of course, where do we get the b and a values from? What is our b value?
1.
Yeah, the b value is the number that's in front of x, which in this case is a positive 1. And the a value is 1/2. So the b value is positive 1 and the a value is 1/2. So then, yeah, up on top, we end up with -1, and on the bottom, 2 times half. You could do that with the calculator. That'll be 1. So what do we end up with? X equals -1. So our vertex x value is -1. And in any situation, whenever you have an x and you want to find the y, all you do is plug it in.
So 0, negative.
Plug it in. Plug it into what? Into the original equation. So I'm going to start by copying down this original equation, but instead of x's, I'm going to put parentheses. So I have y equals 1/2 parentheses squared plus parenthesis minus 3. And we are plugging in a -1 right in there.
So then either way is that.
So let me explain all the details of this math right here. You start with exponents. So you really have a -1 in parentheses to the second power. That's a -1 times itself, -1. -1 times -1 is +1. And of course, you still have the multiplication of 1/2 right in front of it. Okay? Like I said, this is going to be ugly, right? This is actually like more for like algebra 2, but we're good. 1/2 times 1 is 1/2. So we have a 1/2 right here. And then let me just rewrite everything else. I have 1/2 plus -1 and then minus 3. Okay, and that will be our y value. So what does y equal? We have 1/2 plus a -1. What is that? 1/2 plus a -1.
1.5.
That's negative 0.5, or you could say -1/2. Does that make sense? Okay, so so that's like 50 cents, and you owe $1. You're going to owe 50 cents, right?
Yeah.
Okay, and then you owe another $3, so you're going to owe $3.50. So you're going to be owing 3.5. So your y value is really 3.5 or 3.5. Of course, all of this you could do with the calculator. -3.5 or -3.5, right? Or y equals -3 and 1/2. Whatever you want. So, but there's your y value of your vertex. So now let's go back up to the vertex coordinate. Put that y value in there. You could use a decimal or the fraction -3.5 or -3.5. But the bottom line is, our vertex is going to be in a pretty ugly location.
The middle, 3.5.
Yeah. So let's go to -1, -3.5. -1, -1, 2, 3, and halfway is right here in the middle. It's going to be super weird, but it is what it is. So let's put that dot right there in the middle. So there's your vertex. After you draw your vertex, you might as well draw the axis of symmetry, which is just this green dotted line, this vertical line crossing right through that vertex. And since they ask for the equation of this axis of symmetry, what is the equation of the axis of symmetry? You're going to say x equals -1. That's right, the x value of your vertex, which is -1.
Are you going to put the question like that on the test?
I will put an equation and then ask you, write the axis of symmetry equation. You have to type in x equals -1, right? So there'll be different parts, right? Like I could give you this equation and just ask you for the vertex. You type in this vertex. Anyway, let's continue. We need more points. Well, we need points so we could actually map them over to the other side. What is the hands down easiest, quickest point to find on any parabola in standard form?
0.
The y-intercept, right? Where it crosses the y-axis. That will be the location 0, comma what?
-3.
-3. That's your c value, right? Anytime you have it in standard form, you could get the y-intercept. You say 0, comma the c value, and the c value happens to be -3. So we know that it's going to cross at 0, -3, which is right there, that red dot. So you could map it over right now as is. And there's your parabola, bless you. There's your parabola so far. We do see that it's pretty wide, but we need more points. Let's get more points here. So you could go to an XY table and plug in any numbers you want, like plug in 1, plug in 2, plug in 3. Or you could practice modifying the pattern, okay? And let's do that. You see, the original pattern when A equals 1 is 1, 1, 2, 4, 3, 9. But we don't have an A equals 1. We have an A equaling 1/2. So we have to modify the outputs, the 1, the 4, and the 9. We have to modify those by multiplying by 1/2. Like I said, if you understand this, you'll understand any of them. Times 1/2, times 1/2, times 1/2. Giving us new outputs. 1 times 1/2 is 1/2. No problem. 4 times 1/2, that's easy, that's 2. 9 times half, what is half of 9? That's 4.5 or 4.5. If you want decimals, fine. If you want the fraction 4.5, that's fine also. But the bottom line is, this is your new modified pattern. The new modified pattern is 1 to the left or to the right, 1 to the side, and halfway up. And then you go back to the vertex, 2 to the side and 2 up. Then you go back to the vertex, 3 to the side and 4.5 up. So let's do that. From the vertex, if I go 1 to the side, I'll be right here at this halfway point, but I only go halfway up, I end up right there. And we already had that point because we knew that that was a y-intercept. But then we go back to the vertex and go for 2, 2. 2 to the side and 2 up. But notice I'm here at the halfway point, so going 2 up will be 1 to this halfway point and another to that halfway point. So here is 2 units up. So please put a dot right there. And then you go back to the vertex and you go 3 over and 4.5 up. So check that out. 3 over, 1, 2, 3. Now I'm at the halfway point and I need to go 4.5 up. So I'm going to go 1 to that halfway point, 2 to that halfway point, 3 to that halfway point, 4 to that halfway point, and then half. So I'll be at a nice coordinate, at the coordinate 2, 1. And that's about it. All you got to do is map those points over to the other side of the axis of symmetry, and we'll be good to go. So map that one over here. Whoops, I'm sorry. Map this one over 2 units over here to that halfway point. And then this one over here, right? 1, 2, 3, 1, 2, 3, right there. And we have our parabola. Yes, it's wider than usual because it got vertically compressed because the A value is closer to 0. So what else could we state here? We could state the domain and range. The domain of this parabola or any parabola, doesn't matter if it's wide or narrow, if it's opening up or opening down, the domain is x equals all real numbers. Very important that you say x equals, right? The range are your y values, and this parabola, where does it exist in terms of y? Does it exist at 100 up here somewhere on the y value of 100? Yeah, because it's eventually going to get there. Does it exist at the y value of 0? Yes, it's right there and right there. Does it exist at -1? Yes. At -3? Yes. Does it exist at -5?
No.
No. Does it exist at -4?
Nuh-uh.
No. Where does it start existing?
Y is
3.5.
greater than or equal to -3.5.
That's exactly right. Y is greater than or equal to -3.5. That's your range. And that is everything you could possibly state about this parabola. And if you had your page of notes out that we copied yesterday and you went through those, the first thing was a vertex, we found that. The second thing was the axis of symmetry, we drew that and found that, right? X equals the x value of vertex. The third thing was the y-intercept, we got that. The fourth thing was the pattern, or the modified pattern, we got that. And we also had the domain and range all on our notes. So, like I said, this is as hard as it gets.
So that's the fraction of it.
Yeah, that's as hard as it gets. Now, this one over here, I kind of messed up on it, to be honest with you. I should have given you a bigger graph, okay? Because right here, we're still going to be able to graph it, but the graph isn't big enough to show everything. So let's work on this one together here. Number 4, what are we going to start with?
Vertex.
Vertex. Vertex is a coordinate. We find that coordinate using the formula. X equals -b over 2 times a. That's going to be a negative parenthesis over 2 times parenthesis. And let's plug in our b value of 2 and our a value of negative 1/3. So the a value of negative 1/3 is down here, and the b value of 2 is up there. Now, you could get a Casio calculator, and I think you could type this in exactly the way it is, hit equal, and it will give you your answer.
That's 0.6667.
But let me show you how to do it by hand, okay? So let me zoom in to do this work. What we really have here is negative 2 over 2 times negative 1/3, right? When I say 2 times negative 1/3, I want to multiply the top number with the top number. So that'd be a 2 over 1 times 3, 3, and of course a positive times a negative is a negative. However, we should know that a negative divided by a negative is a what? Positive. Or let's say you didn't notice that. That's okay. We do have a number divided by a fraction, and it would make more sense to write it horizontally. Negative 2 divided by negative 2/3. But we could change the division to multiplication as long as we flip the second fraction. You guys remember that? So we really have negative 2 times negative 3/2. Now at this point, you could put the 2 over 1, and you could either cancel and then multiply, or you could multiply and then reduce. It's totally up to you. If you were to multiply, a negative 2 times a negative 3 is a positive 6, and 2 times 1 is 2, giving you a 3 as a final answer. So 3 is x. And I don't think I will do this to you on a quiz, giving you a crazy fraction like that for a. But it is what it is on this one. X does equal 3. You have x, you want y. What do? We plug it back in to the original function. So I'm going to rewrite it. Y equals negative 1/3 x squared plus 2x plus 3, where our x is 3. And we need to do the math here. We're going to begin with exponents. 3 squared, that is 9. But then you have to multiply by negative 1/3. So you could put the 9 over 1 and multiply top with top, bottom with bottom. You're going to end up with negative 9/3, which is really just a negative 3. Negative 9 divided by 3 is negative 3. And then you multiply 2 times 3, and you'll get 6, positive 6. And then you could bring down the plus 3 as well. And this is what our y value is going to be. It's going to be 6. So y is going to be 6. So we found our x and our y. The x was 3 of our vertex. The y was 6 of our vertex. And that's the most important point. So let's go graph that thing. And this is where I said I made a mistake. I didn't make this graph big enough. So this 3 on the x, 6 on the y. Here's 5. You're going to be 1 unit off the graph. But let's graph it anyway. That's a vertex, 3, 6. Second thing to do would be to write the axis of symmetry right through this red dot. So it's a vertical line right through the vertex. And that axis of symmetry equation is x equals the x value of your vertex, which in this case is 3. So x equals 3 will produce the vertical line crossing right through that vertex. So now that we have that reflection line, we need more points, more coordinates. So one easy point to do, the easiest point to do is the y-intercept. The y-intercept will simply be 0, comma, the c value. And what is the c value? The c value is 3. So if I go to that point, 0, comma, 3, 0 on the x, 3 on the y, you end up with that point right there. That's your y-intercept. If you were taking a multiple choice test, you would already know which one is the correct parabola, because you would know the vertex and you know that it has to pass through there. As you could see, you could already imagine that it's a pretty wide parabola to cross through that point, and that makes sense because that's closer to 0. Okay, so it got vertically compressed, and it's opening down because it's negative. But let's say you wanted to practice modifying your pattern. So our pattern that we have to memorize is 1, 1, 2, 4, 3, 9. 1, 1, 2, 4, 3, 9. But we're going to modify this pattern according to the new A value of negative 1/3. So the A value is negative 1/3. So I need to multiply the outputs, the 1, the 4, and the 9. I need to multiply those by negative 1/3. Okay, so on the first one, 1 times negative 1/3 is negative 1/3. On the second one, 4 times negative 1/3, that is negative 4/3, but you could rewrite that as a mixed number or a decimal. I'm going to go with mixed number, negative 1 and 1/3. So that means go down and then go down 1 unit and then down another third of the way, 1 and 1/3. Last but not least, this one's nice. 9 times negative 1/3, that is negative 3. So here's my new modified pattern. I'm sorry. What just happened there? I accidentally erased something. Give me a moment. Okay, there it is. Sorry. So 1 to the side and 1/3 of the way down. Then go back to the vertex, 2 to the side, and then go down 1 and 1/3. Then go back to the vertex, 3 to the side, and then down 3. That's my new modified pattern according to my new A value of negative 1/3. So if I did from the vertex go 1 to the side and 1/3 of the way down, that's not even here. That's only 1/3 of the way down. So let's put that dot right there in space. The graph wasn't big enough. I apologize. And then we go back to the vertex, and we're going to go 2 to the side and 1 1/3 down. So check this out. From here, or from the vertex, you're going to go 2 to the side, and then 1 and 1/3 of the way down. You'd end up right here. And if we did go back to the vertex, 3 to the side, 3 down, check it out. 1, 2, 3 to the side, 1, 2, 3 down, you'd end up right there. But we already knew that because the y-intercept is 0, c, and the c is 3, so 0, 3 is the y-intercept. So we have all the points that we need to graph this thing. If you map them over to the other side, you'll have an accurate graph of the parabola. So again, this one was 1 unit away, so I went 1 unit away right here. This one is 1 unit, 2 units away, so 1 unit, 2 units away right there. This one's 1, 2, 3, 1, 2, 3. I'm 1 unit off, so I'm going to put that last one 1 unit off right there. But that is my parabola. Yes, it's pretty wide. And that's it. How about the domain?
Domain is just going to be all real numbers.
Yep, x equals all real numbers. How about the range?
Y is less than or equal to 6.
Less than or equal to that y value of 6 on the vertex. Perfect. There you go. If you understood that, man, you got it down, right?
100%.
100%. Now, the other ones are easier because the other ones have a value of 3, negative 3. Like, it's pretty easy to modify those patterns from 1, 1, 2, 4, 3, 9, multiplying by 3, as opposed to what we just did right here, multiplying by negative 1/3. So let's take the rest of class to work on the rest of these questions. We've already done half of them. There's only another 4 questions to do. Please check your answers on Google Classroom as you're doing this. And we will have a practice quiz set up soon. And we'll have a quiz at the end of the week.